This is my third video in the local arithmetic or chessboard abacus series. In the last video I was adding and subtracting, so I had the right hand side covered up. But since we're multiplying, we do need the right hand side because these represent groupings. So for instance, this is one group of one, but that's two groups of one and four groups of one. Multiplication is all about grouping. So the first multiplication problem that I'm going to do is 2 times 2. I have some little circles down here. When I put the coins off to the side, what I mean by that is it's just an aid for me to remember what it is that I'm working with. Those aren't actually on the board. They're not actually part of the problem, but it's just a memory aid for me. So in order to multiply, what I'm going to do is put a marker on the board where these two intersect, this row and this column intersect. And then I'm going to slide that diagonally until I hit the bottom row, and that gives me a 4. So 2 times 2 is 4. We noticed in the first video where I was introducing the chessboard abacus that if you slide along a diagonal, the value doesn't change. This is 1 times 4. 2 times 2, which is still 4, and 4 times 1, which is still 4. So all along the diagonal, the value is the same. But I bring it down to the bottom row so that we can easily read that off. So the next one we're going to do is 10 times 6. We know that the answer should be 60. Let's see if that's what we get. So in order to set this up, I'm going to represent a 10. And I'm going to represent a 6. So this is 10 times 6, 6 groups of 10. And in order to represent that on the board, where I'm actually going to be doing the work, I'm going to be placing a coin at the intersection point, all of the intersection points of these rows and these columns. So in this column, I'm going to have 2 coins to go with the 2 in this row. And in this column, I'm going to have 2 coins to go with the 2 in this row. So that's my setup for the multiplication. And then as we saw before, we're going to drag diagonally down into the left so that we hit the bottom row. So this coin, which right now is 2 times 2, I'm going to drag it down so I can easily see that that's a 4. I'm going to drag this down diagonally. Same thing with this coin, and the same thing with this coin. Now, the hardest part about doing this, the two hardest parts are that you have to be able to represent your numbers in binary to begin with. You don't really have to know binary. You can just do some subtracting, subtract off the numbers. But then at the end you have to add. The nice thing is you don't need to know your multiplication facts at all. So looking at this, I could go 32 plus 16 plus 8 plus 4. But it looks easier to say 32 plus 8, that's a 40. 16 plus 4, that's a 20. 40 plus 20 is 60. That's exactly what we were expecting because we know that 10 times 6 is 60. Here we get 40 plus 20, which is 60. So the next example is going to be 13 times 6. So let's write it this way. And it doesn't matter if you put the 13 here and the 6 here or the 6 here and the 13 there. That's the commutative property. It's symmetrical. It doesn't matter. I think I'm going to write it so that we have the 13 over here. So here's our 13. And here's my 6. And then again, I'm going to set this up so that where those rows and columns that have been marked off intersect, those are going to have coins in them. So here, 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 that takes care of this column, matching these rows. And then here, here, here. And then in order to finish up my multiplication, I'm going to drag down and to the left, do any carries that I might need to, any regrouping, and I'm just going to add up the result. These are already in the bottom row. There's nothing to do. Drag this down diagonally, drag this down diagonally, same thing here, and the same thing here. Except when I get to the bottom here, I've got 2 coins in the 16 spot. Well, 2 16s is a 32, and 2 32s is a 64. So there's my answer. Once I have all of the coins that are in that central area down on the bottom row, and I don't have anything doubled up anymore, I've done all my regrouping, I can read off my answer. So what have we got? We've got 64 plus 8 is 72, plus 4 is 76, plus 2 is 78. And it is true that 13 times 6 is 78. With that example, we did need to do a little bit of carrying. So we're going to do one more. Let's do 22 times 6. So let's see, 22. That's going to be a 16, a 4, and a 2. 22. And I want to multiply that by 6. So again, it's very mechanical. We're just going to set this up. Then we're going to drag diagonally down to the left, do whatever regrouping we might need to do, and add up the result to get our answer. So we're doing 22 times 6. Let's drag these down diagonally. It doesn't matter what order you do this in. They're all going to end up where they need to be. Let's bring this one on down. Okay. And then when I slide this one, I've got 2 in the 8 spot. We regroup that to a 16, but now I've got 2 in the 16 spot. That regroups to be a 32, but now I have 2 in the 32 spot. That regroups to be a 64. We've got a lot of regrouping with this one. 2 64s, right, it's all about doubling. 2 64s is just the next number up, which is a 128. Not much adding to do. I have a 128 plus a 4, which is 132. And 22 times 6 is 132.